I'm going to give you a short but kind of long presentation on how to do fraction decomposition. So, I know it's been a while, but as you can see, this is not your typical integral. We have a very complex problem at the bottom, and not so much complex at the top, but if something's complex at the bottom, it's going to be tricky to solve. So, with that, we have a formula to solve this, and that is fraction decomposition. I know it's been a while, but I'll rewrite the formula. We're basically using variables like a, b, and c to solve our problem. So, it'll look like this. We have a over plus b over plus c. I'll give you guys a moment to try to figure out that. Alright, need to fill in? Okay. So, as you can see, we basically do it in order. X is first, so x is going to go under A. And then next, ignore this, we have x plus 1, so that's going to go under B. And then finally, we have x plus 1 to the second power. You got to read it as one whole thing, so that's going to go under C. Alright, cool. So, that's our fraction decomposition. Now we're done. It's like, no, I'm just playing. Okay, so after we set this up, our next step is to set our numerator equal to this and make an equation. Now that might sound rather tricky, but it's rather simple, and I'll go through it right now. So we have 2, let me write that a little bit higher for you guys. 2x to the second plus 5x plus 3 equal to a. Now, you might be thinking to write ax, which would be wrong. You have to go back to your original problem and look. What is a missing? You see right here, a is just x, so it's missing x plus 1 to become the whole problem, the whole denominator. You have to make sure you include everything when you write your equation. So we plug that in to get a times x plus 1 to the second power. Cool. Now we do the same thing for b. What's b missing? B doesn't have an x, and it's missing a x plus 1, so we write b of x and x plus 1. Cool. Finally, we do c, and what's c missing? C already has the x plus 1 to the second power, so c is just missing this little guy right here. X, so we write x. Fire. Now, in order to solve this, there's one important thing that I didn't get. We have to find what numbers make our denominator 0. And it's actually pretty simple. Anything times what is 0? 0. So, let me just draw a down right here. 0. And then, what plus 1 gives us 0? Negative 1. It is that simple, my friends. And then, what we do is we plug these values that we solved, we plug them in for our x. Everywhere you see an x, you plug in one of these numbers, but you start with them one at a time. So first we're going to start with 0. So what I'm going to do is I'm going to bring this guy down here, plug him in, 2 times 0, there's an x, plus 5 times 0 plus 3 equals a, 0 plus 1 to the second power, plus b times 0, 0 plus 1, hope you all can see, plus c times 0. Cool. And as we already know from elementary school math, anything times 0 is just 0, so this goes away, this goes away, this goes away, and this goes away. So on the left side of the equation is 3. And on the right we have 0 plus 1 to the second power, which is just 1. We get a 1. Now remember, we want a by itself, so we can plug him in back up here. So a, just by looking at this, is simply a is equal to 3. Cool, pretty easy, right? Now we have to do the same thing for b and c, which is pretty lengthy, but you'll get used to it. So this time we're going to plug in our negative 1, 2 times negative 1 to the second power plus 5 times negative 1 plus 3. Do the same thing on the right hand side. A times negative 1 plus 1 to the second power plus b times negative 1 plus 1 plus c times negative 1. And as we already know, this is going to equal 0, so get rid of him. This is going to equal 0, so get rid of him. And if you can already notice right now, we're seeing a pattern. When we solve for one variable, typically the other two variables go away in most cases. So let's see if we give up. So this goes away, this goes away. 2, 1 to the second power, negative 1 to the second power is just 1, times 2 is 2, negative 1 times 5 is negative 5, plus 3, negative 5 plus 5 is just 0. So we get 0 is equal to c times negative 1, which is negative 1c. So c would ultimately be 0. Okay, now we're almost done, but we're forgetting. We have to solve for b, and we only have 2 numbers that make this 0. So what do we do? And it's actually quite simple. You can pick any number you want, but I prefer to pick numbers close to 0, and I'll pick 1, and you just plug it in again. So we're gonna plug in 1, and do the same thing we just did. So 2 times 1 to the second power plus 5 times 1 plus 3 is equal to, remember, we solve for a, we solve for c. So we plug in those values that we solve for right here into our new equation. So we get 3 times 1 plus 1 to the second power plus b, which we don't know, 1 plus 1 plus 0 times 1. And as we've been doing with this whole problem, if it's 0, it goes away. Cool. So 1 to the second power is just 2, 5 times 1 is 5, plus 3, we get 10. 1 plus 1 is 2, 2 to the second power is 4, 4 times 3 is 12. Plus 1 plus 1 is 2, 1 is b, 2, that equals 2. And we don't have to worry about that guy, so he just goes away, and now we just solve for b. So subtract 12 on both sides to get 12 minus 10. 10 minus 12 is negative 2, equals b2. And negative 2 divided by 2 is just negative 1. Cool. B equals negative 1. All right, so now we did the hard part, and next, all we have to do is plug in 1, 2, 3, circle that, back into here. So what I'll do is rewrite our new integral on this side. So the integral of 2x to the second power plus 5x plus 3 over x times x plus 1 to the second power is now equal to the integral of a, 3, plus b, negative 1, plus c, which is 0. Now we already know what happens when there's 0. This guy goes away. Make sure to multiply it by dx because we're taking the integral. And now what I'd like to do is split these guys up. So we have 3 over x dx minus this guy comes front. This guy comes before the integral sign or the integral sign like this. So just imagine there's a negative 1 here. So we get dx over x plus 1. Cool. And now, if you recall that 1 over x is equal to ln of absolute value of x. 1 comes right here, x goes right here. Do the same thing with these right here. So it's going to be 3 ln of x, right? 3 came right here, x went right here, minus ln, negative 1 went right here, x plus 1 goes in between. Cool, now we're almost done, but not quite yet. Now we have to simplify, and if you all can recall again, I'll write it right here, that a constant of ln of x equals ln of x, with that constant multiplied to a power. So that's what we're going to do to our friend right here, which is going to give us ln of x to the third power minus ln of x plus 1. Cool. Don't forget your absolute value signs. Now, we can simplify one more time. If you recall again, that ln of a minus ln of b is equal to ln of a minus b. So we do that right here. This is our a, it's positive. This is our b because it's negative. Negative. So we get ln of x to the third power over x plus 1. Cool. Now you might be asking yourself, aren't we missing c? It's an indefinite integral. Every time we have an indefinite integral, we plug in c as our constant. That is correct, but we can do something a little bit different in this situation because we're dealing with logarithms. So what we're going to do is say plus k. Now, I'm using k to represent all possible values of c. And because I did that, I can say k is equal to ln of c. And now that I did that, I can take this ln and plug it in here because ln times this and see what this move inside. So what that would look like is ln of x3 over x plus 1 plus k is equal to ln c times x over 3 x plus 1. And boom, that's our answer. So we use your absolute value signs and things like that. Yeah, rather long tutorial, but that is a quick presentation on how you can solve a fraction decomposition problem. And thank you. Check out Aiden's video. We did it 2 different ways.
Shout out Aiden.